In this video, we're going to do a few examples where we're sketching graphs of piecewise functions. Okay, so let's go ahead and get started. First off, let's try to understand what this means. So, f of x is the function, and it can take two possible, it can take this equation or this equation, depending on what x is. So if x is less than 0, then we take on this, 2x plus 3. If x is greater than 0, then f of x is square root of x. So let me go ahead and do a graph here. Okay, so let's go ahead and start graphing this. First, I'm going to graph when x is less than 0. So when x is less than 0, y is 2x plus 3. So to do that, I'm going to go ahead and just plug in a few points. So I'm going to plug in -2 first. So that'll be 2 times -2 plus 3. So that's -4 plus 3, which is -1. Okay. So so the point then will be -2, -1. So that'll be x is -2, y is -1, so that's right about there. Then let's plug in the point -1. 2, -1 plus 3, so that'll be -2 plus 3, which is 1. So that'll be here. Okay. Then let's plug in, well, if we were to plug in 0, then we're no longer in this part, we're here, okay? But I am going to plug in 0 for this part because as we get infinitely close to 0, so we're getting really close to 0, but we're not necessarily equaling 0, we still have this function, okay? So I'm going to plug in a 0, and I'm going to go ahead and do this in a different color. So it's kind of, it's not, this isn't what f of x is going to actually equal, but we're plugging in. So we'll have 2 times 0 plus 3, which is, so that's basically 3. Okay, so f of x doesn't equal 3, but it's, so I have like an open dot there, okay? So when x equals 0, I don't equal 3, but I get really close to it. So I'll have the open dot there. Okay, so then when I'm drawing my graph, since this is a straight line, right, 2x plus 3 is a straight line, it'll look like this. And then it'll continue going down forever, so that's why I have an arrow there. Okay, so I'm getting infinitely close to where x equals 0, but when x equals 0, this is no longer the what y equals. Okay, when x equals 0, y equals the square root of x. Alright, so when x equals 0, y equals the square root of x. So that would actually be 0. So the point, the solid point, would be there. Alright, and then when x equals 1, the square root of 1 is 1. Okay, so there's a point there. And then for convenience, I'll put in 4. Square root of 4 is 2. Okay, so we should by now know, in the previous video I also showed, the square root looks like this, right? So y equals the square root of x. It looks like this. So when I'm drawing this, I should draw a curved line going like that, and it goes on forever to the right. Okay, so now let's find the domain and range. So first let's start with the domain. Now we see that our arrows, we continue going forever in the negative direction. We continue going forever in the positive direction. So the domain will be -infinity to infinity. Okay, now let's talk about the range. So for the range, going for y now, where's, are we restricted with anything for y? Again, we continue going forever in the negative direction, and then also this very slowly, but does eventually, reach all the way up to infinity for the positive direction. So both from -infinity to infinity, that's also the range. Okay, so now let's move on to another example. So let's go ahead and let's understand this. So when x is less than 1, y is going to be 1 over x. Okay, and you guys remember what the 1 over x graph looks like? Looks something like this. Talked about this in the previous video, but if you're still a little unsure about it, make sure you go ahead and plot a few points and double check yourself that you see that it looks like this. Okay. Okay, so then when x is greater than 1, the y is going to be the x cubed, right? So what does the x cubed graph look like? Talked about this in the previous video, but just talk about it here. It looks something like that. Okay, so let's go ahead and get started. Let's start with when x is less than or equal to 1. So when it's less than or equal to 1, we have, so let me look at this. So 1 is about right here for this graph here. So 1 is about right here. So basically, we're going to have this side, and we're going to have this side up until the point we get to 1. So this graph also, it goes through the point, this point right here is 1, 1, right? Because 1 over 1 is 1. So I'm going to go ahead and put a point there. I'm also going to put a point at negative 1 and 1, because negative 1 over 1 is also negative 1. Okay, and then my graph, I'm going to go ahead and draw this. So I'm getting, infinitely closer to 0 here. And then I turn around and I look like this, and I'm getting infinitely closer to 0 over here. Okay, so I'm getting really close to the axes. So this should look like a curve that's getting really close to their axes. And then on this side, I have the side that looks like it's getting really close over here. Okay, but then I don't go on to draw this part here, because I stop so this is just for when x is less than or equal to 1. Okay, and now when I have x is greater than 1, now I have the x cubed graph, which looks like this. Alright, so let's go ahead and plug in, if it were equal to 1, where would this be, okay? And that's where I'll have the open dot. So where is it equal to 1? So 1 cubed, if x is 1, then 1 cubed is 1, right? So there's an open dot there at 1, 1, but it's already been filled by the previous, it's already been filled by this part. So there's no open dot, so it is filled already. Okay, then I move on from that point. So when x is 2, y is 8, right? 2 cubed is 8. So it looks like this. And then so now I have to have this sort of shape, right? So I'm going to have that sort of shape, okay? And then it continues to go on like forever up there, okay? Okay, so now let's talk about the domain and range. So what is domain? Domain are the values of x that are in this graph. Now, there's one value of x that's not here. So this going from negative infinity, all the different values of x, because there's an arrow there. So yeah, from negative infinity all the way. But then once we get here, there's no value where x equals 0, right? As a matter of fact, if you were to plug in 0 here, you'd have 1 over 0, which is undefined. So x equals 0 is not allowed. It's not part of the domain. And then in this direction, all the way to infinity, you have values of x. So the domain is negative infinity to 0, and then 0 to infinity. Remember, this soft bracket doesn't include 0. Okay? And then the range, so the range are the different values of y. So let's look at the graph. Now, y. Okay, so I'm looking for what values of y aren't here. So from positive infinity, yeah, all the different values of y are here. From negative infinity, all the different values of y. But then there's this jump here. Okay, so talking on this side, this gets infinitely close to 0, to y equals 0 over here. Okay, so this is getting really close to 0. So basically, so the range then from negative infinity will go all the way to 0, but it won't include 0. It'll get really close to 0 right here. It'll get really close to 0 right here. But then up here, it doesn't get really close to 0 because we got cut off, you know, because once x equaled 1, we started to have to follow this graph, you know. So, you know, the lowest the range gets over here is 1, right? And then it goes from 1 to infinity, but it stops there at 1. There's no, like, getting close to 0 that you would have if you had the full graph of, you know, 1 over x like you do over here. Okay, you get really close to 0, but you don't have that. You stop there at 1. So the range then would be, so in unison with, now I include 1 because 1 is here in the range. There's a solid dot there, so 1 is allowed in the range, but then from 1 all the way to infinity. Okay?